Hello and welcome to my 6.3 numerical model. The numerical model is a form of quantitative analysis in which we use to analyse technique and sports performance, analysing the biomechanics of a technique, in this way means that we advise athletes to make small changes to their form in order to perform at their maximum efficiency. The numerical model is produced in a variety of ways. These include such things as literature-based collection, elite level athlete based, and specific athlete based on a combination approach. With a literature base, this might be produced through reading about certain forces and impulses which a team might create, such as a basketball team when using a force plate. This will be relevant to the basketball players as we'll be able to do this motion when boxing out or going for a layup. We can see how much force each player will generate and see the angles which they might create when using this. A lot of this research is done through where the data might be collected from. This then generates the mathematical model which is analysed and looked at by the researcher. The literature-based approach is quantitative data, which uses high amounts of detail and is also a scientific research. As the researcher has read about the numerical model, he is able to adapt his research to what he has read, meaning he will be able to advise them on how to apply more force and a slight change in technique, which will improve their efficiency of their training. Another way in which the numerical model is produced is through elite level athletes. An individual who wants to produce this data will watch and possibly record elite level athletes. This will be used to watch perfect technique and how they are building up momentum or producing the highest speed possible through their technique. This will be looked at through biomechanics, such as angles, such as in basketball when a player bends all the way down and uses their arm to apply a large force for a high jump, or they simply jump straight away without bending down from their power base position in a box out or a dunk. We then analyse their velocity, speed, and many other ways to produce the perfect model, which will then be used for other performers. The last way is a combination approach. This is a mixture of both literature and watching, analysing an elite-based athlete. The researcher may come with the literature-based knowledge, and then the performer perform research on elite athletes, analysing their performance and watching their techniques. This will give the researcher a large amount of data, so they will come with some knowledge and possibly learn more once they have watched the elite athletes. They will see how much force is generated from the athletes and how their technique might be contributing towards the most force. We use biomechanics, which is the application of mechanics to the human body and sporting implements, which here we study the forces of the human body and subsequent force also. This includes both kinetics and somatics within numerical model. Kinetics is a branch of mechanics which deal with the actions of the forces and see which is opposite force, or how large the force is actually going to produce, or how large the force is actually going to produce the athlete to jump a certain height or so. This includes linear kinetics such as the force of gravity and the mass and the weight of an object of human. It also includes angular kinetics, which is the torque and levers. Kinetics is either the action or the force which is producing a motion or causing the change of motion. For example, this would be a basketball jumping up, which is producing a motion of upwards. We'd be able to measure the force produced and repelling force against them with kinetics. This is normally paired with Newton's third law. Somatics is the mechanics of motion which doesn't reference the forces which causes the motion. This includes a wider range of things which is applied to more often. It uses linear motion, curvilinear motion, angular motion, which is around an axis, and also general motion, which uses both linear and angular motion together. It deals with more than the actual motion of the movement. This is the knowledge around the displacement and velocity of the body's segment and joints. An example of this would be mass times acceleration to find out the basketball's force produced. There are two types of motion. One of these includes linear motion. This is where the movement of an object or something with a straight line. This is where all body parts of an object are traveling in the same direction, the same distance, and same speed. This can be seen from basketball pass, for example, the chest pass. The ball travels straight and clips the motion, showing a linear angle of motion. The ball motion is the angular. The other motion is the angular motion. This is where our body produces force, which causes an angular motion of our joints or around the whole body. It moves within a circle or part of a circle about a particular joint which is the axis of rotation. Projection motion is another way of motion. It's when an object travels at a curved angle due to the resistance of gravity dragging the mass of the object back down to Earth. This can be seen within basketball when the shot is taken a shot up high and travels up, showing its beating gravity. However, over time it begins to come back down, creating the angle of the shot. Overall, the numerical model is used to analyse the angles and the force generated from specific movements and actions, such as jumping within basketball and taking shots, which can be seen at either linear, angular, or projection motion. We are also able to see how the numerical models generate through the three ways of processing them. Then we use to analyze a performer during that performance. Linear motion includes various parts which we can break down. This includes scalars and vectors. Scalars gives us the information about the size of something, for example, the amount of force applied in a jump. They are only able to tell us about the size of something, nothing else, whereas vectors are more important in linear motion, as it shows the movement is actually linear or not. They give us information about the size and direction of force. An example of a vector is a displacement. This is the same as distance, with the object has travelled in a particular direction. It measures where the initial position of an object is and then the final position. Then the mathematical displacement is given. Velocity is also important. This is displacement in one direction with an interval of time. It's about displacement change over a period of time. The rate of change of its position over time is the equivalent to an object's speed and direction of motion. Speed is velocity with magnitude of the object. It's calculated through the distance travelled divided by over time. These two factors then contribute to acceleration. This is the rate of change of the velocity of an athlete, which is the change of velocity over a period of time. For example, if the athlete's velocity was higher over a short period of time, then their acceleration would increase. We then move on to force. Inertia within forces is a reluctancy to change. This is where the object or the body is at rest or is it moving at constant velocity in a straight line, meaning it will continue with this unless an external force is placed on to stop this. This is also part of Newton's first law. Force has five main factors which affect it, which play a role within the force itself. Force is the product of the mass, object, and acceleration of an object or person. It is labelled as F equals m times a. All motion is created by a force. It's either a push or a pull force, and it's acted on an object. Force is a vector, however force can be applied with or without contact. There are also several types of force included: internal, external, horizontal, and vertical. Internal forces are the contractions of muscles. There are no other internal forces which are applied to us. This could be when we squat down to jump up the ball to catch the ball in basketball. Let's contract, which is an external force, which is an internal force. The external forces are much more broad. This includes applied force, air resistance, gravity, weight, drag, and friction. A few applications can be seen here in basketball. For example, friction is when the ball is rolling on the floor, and the friction between the floor and the ball causes the ball to slow down. Gravity and air resistance can also be seen. Gravity is when the ball is being dragged down with powerful force when the ball has been thrown to shoot for a shot or any time the ball is in the air. Air resistance is also when the ball is being thrown. The force from the air resistance decelerates the velocity of the ball within the air, causing it to slow down over time. There are many applied forces which can take place. One of these could be within a pass. The player passes the ball with an applied force, causing the ball to travel. Horizontal forces include friction and air resistance, and vertical forces can be weight and normal reaction. Weight is always verticalized, aiming to keep us on the floor due to gravity. The five effects within force are rest motion, change of direction, acceleration, change of shape, and deceleration. Rest motion is inertia where no force is being applied to move the object and they are not travelling any shape of motion. Change directions where, for example, a basketball is thrown at the backboard and it changes within the direction which the ball was originally moving in. Acceleration is the velocity of the object increasing. For example, the ball may be travelling slowly on the floor and someone applies force by slapping it, causing an increase of acceleration and velocity. The change of shape would be where someone slaps the ball, causing a lot of force to be applied to the ball, meaning the shape of the ball will change also. Deceleration is where the velocity decreases due to several factors. One of these could be friction from rolling on the floor, causing the ball to slow down. There are four types of motion, which is linear motion, angular motion, general motion, and projectiles, which I've also discussed. We then move on to Newton's first law. This is inertia. This is where the force is reluctant change, which I've already discussed. This is also part of Newton's first law of motion. This is where all forces are balanced, causing no movement, which is reluctant to change. They are equal in opposite directions, causing no acceleration, meaning there is a net zero force of 0 and no change in motion. However, inertia can also be applied through motion if there is a balanced force. This could be a constant velocity or speed, and there is no change in motion. This can be seen through the ball is traveling through the air in the basketball in one motion. We have to have no resistance, meaning the velocity would stay constant. Newton's second law. This is acceleration. This is a product of the net force being applied directly proportional to the magnitude of the net force and in the same direction of the net force, which is inversely proportional to the mass of the object. It includes the size and direction of the force, which determines the amount of speed and acceleration. This is caused through unbalanced forces. If the forces are unbalanced, there is an acceleration, which depends on the amount of net force applied. An example of this in basketball is the sprint. The force applied is larger than the amount of air resistance which they might face when causing them to accelerate. The amount of force applied must also overcome the internal mass, which is to generate motion. Mass is a constant value which doesn't change. We use it to accelerate to calculate the force applied. Newton's third law. This states that the third law is the action and reaction forces. This is where every force or action has an equal opposite to it. This is called a reactive force. For example, basketball, if a player jumps up, there will be an equal force to their action force. We then move on to impulse. Impulse is in a simple form is another way of describing force. It's how it calculates force over a length of time. The force is applied to an object or a body. It's very much related to momentum as it caused due to the change within momentum of something. It's measured through force times time. And momentum is described as the amount of motion which is being possessed by moving objects and is the product of mass times velocity. It's the tendency for a moving object to keep moving once it's within motion. It can be built up or slowed down as well. For example, if we place the basketball in the air and begins to fall, it will slowly pick up momentum, getting faster and faster as the velocity of the mass is increasing, causing a higher momentum. It's measured in kg per millisecond per second. If we apply momentum to a basketball and use a 90 kg player travelling at 10 milliseconds minus 1 second velocity, the momentum would be 900 kg ms minus 1. The mass through the momentum stays the same in either the object or the player. However, it will travel at a constant momentum and changes due to acceleration or deceleration. Stability and instability. Mass is the amount of material which an object is made of and the measurement of it. It's also described as distribution of mass. Mass has a certain centre of mass. This can be different throughout many people, positions they're in, movement they are doing. It's at the point at which all the body is balanced in every direction. In centre of mass, gravity is also at the centre of the individual. It acts down through the centre of mass and the centre of mass line, so it goes through here. For example, if a basketballer was to jump up with his leg bent from the jump, his centre of mass would change and there would be a reactive force which acts through the centre of mass. It would be very different from when he was standing on the floor due to the movement of the body. There can also be a reaction force which takes place outside of the centre of mass. This is rotation. This is when rotation is taking place within the movement. This might be during a box out in basketball when an individual must rotate on landing. The reaction force would be outside of the centre of mass. Stability relates to how difficult it might be to disturb the body from a balanced position. There are different types of stability. Some are stronger than others depending on the body position of the individual.